Here we are at question 3 of the January 2025 CSEC Mathematics Paper 2. Now this question, it says, the diagram below shows a regular hexagon LMNOPQ whose side is 8 centimeter. Show that the value of the angle PQL is 120 degrees. PQL. Alright, so we just copy it, paste it over here. Alright, when it comes to this situation, right, if we know the total internal angles of the pentagon or of the hexagon, all we have to do is divide it by 6. That's one way you could do it. But how do we know? There is a certain formula, but let's not try to remember the formula yet for the total internal angle of a polygon. Let's look at a basic polygon here, the triangle. What's the total internal angle of the triangle? You know it is 180 degrees, alright? You have this plus this plus this. Call this A, call this B, call this C. So A plus B plus C is 180. For example, if you have an equilateral triangle, 60, 60, 60, they add up to 180. Now, if you should have a situation like this, imagine you have a triangle, and this height of the triangle is getting smaller and smaller. This angle getting wider and these getting narrower. These angles are approaching 0. This one would be approaching what? A straight line, 180. So you can see that the internal angles of a triangle indeed add up to 180 degrees. Now, remember, we're not going to just look doing the question here. I want to discuss the theory behind the question, right? Now, if you have a quadrilateral, 4 sides, right? You have 4 right angles. 490 degrees, 90 times 4 is 360. So the quadrilateral contains 360 degrees. Now, another way to look at the quadrilateral is that you can divide the quadrilateral into 2 triangles. Now here you have this triangle, this angle, and this angle. Call this A, B, C. A plus B plus C is what? 180. And then you have D, E, F. What is D plus E plus F? It's 180. Right? So if you consider A plus C plus F plus E plus B plus D, they would all add up to 180 plus 180. Right? Which would be 360. Because you'd have A plus B plus D plus E plus F plus C. A, B, C, D, E, and F all add up to 180 plus 180, which is 360. Now, how many triangles does the quadrilateral have? There are 2. So you can form 2 triangles here. 2 times 180 is 360. Do you remember the number of sides that a pentagon has? 1, 2, 3, 4, 5. It's 5. Or do you remember the total internal angles of a pentagon? Well, doesn't matter. We are going to find out. From a diagonal here and a diagonal here, how many triangles do you have? There are 1, 2, 3 triangles. If you add A, B, C, D, E, F, G, H, I. Now, this plus this plus this is 180. Plus this plus this plus this give you 180 for the second triangle, and then plus this give you 180 for the third triangle. How many triangles it contains is 3. Now the total angle would be 3 times 180, which is 3003 is 24, bring down the 4, carry 2, 3, 1, 3, 4, 5, 540 degrees, right? Now, that is 5 sides minus 2 gives you 3 triangles. So it's 3 times 180. In the case of the quadrilateral, it is 4 sides minus 2 equals 2 triangles. 2 times 180 gives you 360. Right? So you can have any quadrilateral. Once you divide them up into triangles by drawing diagonals, just count the number of triangles, you get the number of 180 degrees inside. So they all add up to that. Now let's look at this. If you say you divide here, number of triangles, so starting from one of these vertices, you divide it into triangles. How many triangles do you have? 1, 2, 3, 4 triangles, which is 6 sides minus 4. I mean minus 2, not 2, 4. Minus 2 equals 4 triangles. Now the formula for the total internal angles of a polygon is n number of sides minus 2 times 180. Because n minus 2 gives you the number of triangles you can form inside the polygon from one of the vertices by drawing diagonals. And then you multiply that by the number of angles. Because the angles, you have this plus this plus this give 180, plus this plus this plus this give you 180, plus this plus this plus this gives you 180, plus this plus this plus this give 180. So you have 1, 2, 3, 4 cases where you add up 180s, right? So 180 times 4, 4004 is 32, bring down the 2, carry 3, 4, 1, 4, 5, 6, 7. It's 720 degrees. Total. Now it is 720 degrees and all of them are the same size angles. Then 720 divided by the 6 sides gives you, now 720 over 6. And say 6 into 6, 1. 6 into 7 goes 1 time. And 1, 6 into 12 is 2 times. Add the 0, so you get 120 degrees, alright? Alright, so it was just a discussion on how you would get this. This is part A. Let's see what the other part is like. Next part of the question. Oh, part 2. The vertices of a rectangle WXYZ touch the sides of PQ, QL, MN, and NO of the hexagon. In part A, ZY and W, so ZY and WX are parallel. Okay, you can see that. parallel to LM and PQ. Once you see the arrows, you show that they're parallel. So you calculate the angle LWX. Alright, we'll do that in the next video.